when you're looking at free body diagrams, go through the list of forces that are possible, choosing the forces in order that you want to work with. What's the first force you should start with? Gravity. Gravity's always going to be pointing which way? Down. After gravity, what's the next question you should ask?
Friction.
Before you get to friction. Is the object touching something else? If so, there's going to be a normal force. Then, ask if it's moving or trying to move, which is where friction would come into play. After that, ask if there's a spring, which would be spring force, or a rope, which would be a tension force. And then you can potentially talk about air resistance. We're going to leave that out in most cases.
Is that what ATP is?
No, that's force applied. If you don't know the name of the force, you can do force applied. We'll generally know the names. Okay, so number one, a book is resting on a tabletop. What should be the first force we draw?
Force of gravity.
Gravity.
Down. Force of gravity.
Force gravity going down. Second question, is it touching anything?
Yes.
The table. So the table surface is right here. Normal force always acts perpendicular to the surface. So which way is the table pushing the book? Perpendicular, 90-degree angle to the surface. These two are equal. Why are they equal?
Because it's two force.
Two different forces. They can't do it. They're law.
Downhill.
The acceleration of this book is what?
0.
0. F net equals ma. So if acceleration is 0, the net force is 0. Net force means the sum of all the forces. So these two have to add to 0. Same length in each direction.
So force that you're not putting in is force of gravity.
The acceleration is 9.81. The force is whatever the force of gravity is on this object, its mass times 9.81 would be the force. Okay, the second one. A girl is hanging from a rope. Hanging on a rope.
Oh, what is it hang from?
It says from.
Oh, serious.
It doesn't mean it that way. The diagram of the force is acting on the girl as she holds the rope. Holding the rope. What force is there be on her?
Tension.
Gravity. The first one we always start with is gravity. Is she touching anything? A rope, but is she touching any object? No. So no normal force, therefore no frictional force. Is there a spring? Is there a rope? Which way would the rope pull? So there's a tension force going up, and those would be equal because she's motionless. She's not falling, she's not climbing the rope. Okay, 3. An egg is free falling from a nest in a tree. Neglect air resistance. What force would there be on the egg?
Gravity.
Start with gravity. Okay, then go through our list. Is it touching anything? Is there a spring?
No.
Is there a rope?
No.
Should we include air resistance?
No.
We're done. That's the only force. Which way is it going to accelerate?
Down.
Would you expect an egg falling from a tree to accelerate down?
Yeah, so would.
Good. An egg is falling, not freely, not neglect air resistance, from a nest in a tree. Diagram the forces acting on the egg as it falls. So this one, still force gravity, still not touching anything, still not any rope, still not any string, but now we're going to include what?
Air resistance.
Which way is air going to go?
Up.
Up. Okay, 5. A rightward force is applied to a book in order to move it across the desk with a rightward acceleration. What forces would there be on the book?
Gravity.
Gravity, going which way?
Down.
Down. Is it touching anything?
Dead.
What's it touching?
The table.
The desk.
Yes.
So there's normal force from the desk. It's pushing up. What else is touching it?
There's another normal force on it.
There's another normal force pushing it to the right. Is there a rope? Is there a string?
No.
Is it moving or trying to move?
Yeah.
So what would we else would we have?
Friction.
Friction. Going which way?
Opposite direction.
Is it going to be the same as normal force, less or more?
Less.
Less. Why so it's less?
Because the body said it's moving.
It's accelerating to the right. So there's got to be more force to the right than to the left. Friction always goes parallel to the surface in the opposite direction of motion. A rightward force is applied to a book in order to move it across the desk at a constant velocity. How is this one going to be different? There's a rightward force applied. What's going to be different if it's at a constant velocity? What's the same? Friction has to be the same as the normal force. They cancel each other out because the acceleration is zero. Constant velocity means zero acceleration.
Oh, man.
Constant velocity.
It's just moving.
Yeah, but it's not accelerating. Acceleration is a change in velocity.
What exactly is normal force?
Normal force is any time two surfaces are touching each other. So like you're sitting in the chair is pushing up on you, that's a normal force.
Down.
It's going towards me.
Opposite force gravity.
Gravity's pulling you down.
Right.
The chair is pushing you up. Spring force is FS. When we have a spring, we just haven't had one of those yet. Car is stopped at the stoplight.
Gravity.
Force gravity.
Normal force.
Force normal. Anything else? It's not trying to move.
Stopped.
It's stopped. So nothing else. Skydiver is descending at a constant velocity.
Force gravity.
There's gravity pulling down. What's pushing up?
Force air.
Could be, I would take in this case, either air or tension. Why would I take tension?
Because of the tension of the...
It's actually a combination of the two. Air is pushing up.
Parachute.
The parachute is attached to a knot by what?
That's totally tension. By rope.
By ropes. So that's tension force.
It's
Okay. This one illustrates a very important point. Car is parked on a slope.
Force gravity.
Gravity's going down.
Force normal is going up.
Force normal is going up, but force normal is always perpendicular to the surface.
So it's going to be for the...
The surface is here, so it's got to be perpendicular to that. The force normal is going that way. Perpendicular to the surface, 90-degree angle.
Would everyone go that way because it's...
Is there a rope?
No.
Spring?
No.
Is it trying to move?
Well, it's going downhill, so yeah.
If there were no other force, what would be happening to it?
It'd be going down.
It'd be sliding down. So what's keeping it from sliding down?
There's a friction.
It's a frictional force going up. Slope.
Have a frictional force, don't you need the other one?
You have to have normal before you can have friction.
So a normal force.
You can't have friction without two objects touching.
So should normal go down then?
So what we
They don't have to count. They're not opposite forces. They just both have to be there.
normal if you going down.
The opposite of friction would be the friction on the road. So if you did a diagram of the road, it would be going down.
Then why do you use normal down?
That's something pushing. This is friction of the tire. A hot air balloon is accelerating upwards. What forces do we have? Gravity first. And then we have what? It's really the force of the balloon. It's not, I wouldn't call it air resistance. Air resistance is trying to keep it from moving. So this is actually, it's always going in the opposite direction. The balloon's pushing up the direction it's going. It's due to the heat difference, the density difference of the air inside the balloon and outside the balloon. You could just, we don't have a specific name for that one that we've gone over. The car is coasting to the right and slowing down. What would we have? Force of gravity.
It's force of gravity and every single one.
As long as we're on the Earth, we're on a planet.
Even if we're in space, there's kind of gravity.
There would be gravity, it's a lot smaller.
Yeah.
You got, no, you really can't get far enough away, that wouldn't be.
Yeah, because you're always going to have a little bit of
Very little bit.
Force.
Force normal, pushy which way? What else?
Force.
force normal to the right,
It's going to the right and slowing down.
Friction to the left.
friction to the left, force normal to the right.
Are you
Friction
applying a
high.
force forward?
No, but
Trying towards the left.
yeah, but there is one.
The car's not pushing forward, it's not trying to speed up, it's not applying a force forward.
But double.
There is friction slowing it down and going the other way, that's why it's slowing down. Acceleration's in the opposite direction it's moving when it slows down.